All right, good afternoon, everyone. Really happy to be here. I'm really looking forward to workshops tomorrow morning, getting into the nitty-gritty with a few of you, whoever will still be here. And what I'm really excited about with those workshops is getting into why GraphQL is just not modular enough. I'm Matt Mahoney. I work on our native iOS and Android clients at Meta. And helping me give this talk, getting deep into the weeds, will be Mofei and Dave, who are both on the Relay team at Meta. And yeah, so at its core, GraphQL was built and was designed to be a modular system. And what I mean by that is, like, you have your requirements on the server. We didn't want to have REST endpoints that are one-to-one mapping with your, every time you have a new client usage, you have to build up a new REST endpoint. Like, GraphQL was built to break that apart so that your server engineers could iterate and your client engineers could iterate, and they didn't have to be so tightly coupled. Really, modularity is about enabling composition. You know that you're modular if your system has some good properties, right? When you make a change to one subsystem, it doesn't have to infiltrate all the other places. You can just make your change in one place and be done. You don't need to test every single surface that your component could possibly be on. You just test your change in one location, and you can trust that it's going to work everywhere. And if you're using a build system, when you make a change, that change is fast. You're only modifying your local thing. You can make your change, reload your browser, and see it immediately, right? That's the ideal developer experience. On the other hand, we can talk about entanglement, right? When it's not modular, what does it feel like? And you know when you're in an entangled state. It's really obvious, right? Your system is just infected with implementation details. When I go to change one location of code, I have to do a whole system-wide refactor. It sucks. You can silently have your parent components break on you, right? Like, I changed my component, I tested it locally, everything looks good to me, and suddenly some view way out in the weeds that I didn't even know exist comes shouting at me and is like, Matt, why did you break our product? And another aspect that's close to my heart is that the developer experience also stinks. You end up waiting on builds that just take minutes when you're only changing, like, the color of, like, a component. It sucks not to be modular. It sucks to have an entangled system. As I said earlier, GraphQL was built to enable modularity, to disentangle the problems of the server from the problems of the client. You should be able to have your server expose what its capabilities are and build products based off those capabilities without having to go to a server engineer every time and ask them, hey, I'm trying to make this change, it doesn't quite work, can you fix your system for me? We like to be able to have products that hit similar but not quite identical server capabilities, so they might hit the same field, use the same resolvers, but when I ask for more information in, say, the group's product view, I don't have to worry that the response shape in newsfeed is going to change on me, right? And these new features, when I build groups, I don't need to make a custom groups endpoint. I can just compose the capabilities that the server's already provided me. Similarly, GraphQL was built with a modularity tool for client development. We knew that you would want to decompose your product into a tree that has different subcomponents, and you'd have teams that are working on these different subcomponents. You'll have a team or an individual developer building up an image component. You'll have an individual developer composing that image component into a detail component to describe who's actually giving this talk. And this modularity hints at a promise that GraphQL gets so close to, and yet we struggle with. To talk more about how we struggle with fragment modularity, I'm going to hand it over to Dave.
Thanks, Matt. It is so good to be here in person with everybody. I am just really glad about it. So I'm Dave. I work on Relay at Meta. So Relay is our GraphQL client for JavaScript and React. And like Matt said, GraphQL is supposed to be all about making things modular and separating out components so that they can be developed independently. And there's just a few things that are where it's falling short. And if we fix those things, we'll actually have this really ideal developer experience where things are really modular. So this is sort of how we think about modularity. What the definition of it is first of all, if you're making a change to some code, your changes should be local to the thing that you're working on. You shouldn't have to go change unrelated stuff whenever you make a change. Okay, so that's sort of the obvious thing. Also, when you make your change, you shouldn't have things break, right? You shouldn't have some runtime problem in a different product because of your changes, right? You should have confidence that you make the change, you've tested your stuff, and everything else is fine, right? Because it's modular, it's separated out. And then a less obvious aspect of modularity, though, that's equally important, is that when you make a change, if it's a small change, it should be a fast build step if you're doing any type of builds. If your build system is like O of the size of the code base, that is because there's some interdependency between different things in your code that your compiler or whatever is having to check, right? So if there's something that can't be incremental, it's because it's not modular, and that will result in a slower and slower developer experience. So the way that, okay, the promise of the clicker is somewhat like the promise of modularity in GraphQL. So I'm going to go back up here. This will work. Suppose that you are developing a component to show the details about this conference talk. So you've got the talk description, and you've got the different presenters. Like Matt said, the GraphQL is very, very effective at making the server and the client modular with regards to each other. So you don't have to like make a new server endpoint every time that you are developing a new feature. You can just take the things that the server already does and recompose them together. But also, we want our user interface to be broken up into different components that are separate from each other, and then we can compose those into a tree. So like, let's say we were developing the lavender part there, which is the presenter profile. We might have, for example, a React component, and it is comprised of a couple of subcomponents, a title and an item picture, right? But all of these need to get the data about the presenter from somewhere. So the way that this API looks in Relay is we have a React hook called useFragment, and you put a GraphQL fragment in there. Now, what's beautiful about this is that that component is self-contained. It says what data it needs. It needs the name, which is being used directly in this component, and then whatever item picture is using, you take its fragment, you compose it into yours, and so you can just, in this one component, if you wanted to add some other information about the presenter, you just put it in the fragment, you put it in your, in your React output, and you'd be done. It's like totally local, self-contained. We call this data co-location. And that is what we would like to have, but it's sort of like not, it's not actually as beautiful as this, to where you can't break any other components here. Like you'd like to think that you can remove name or add something else without breaking anything. That's not true. Now, just some context for where these problems come up is that fragments are going to be used frequently in many different operations or queries, right? Like you could have a single component that's used in thousands of places, and so that fragment could be composed into thousands of different queries, right? Or different contexts. Similarly, any given query could have a huge tree of components that it is serving. They're just getting put into it, right? So you could have your fragment that's supposed to be self-contained sitting along other fragments that you didn't expect because they're actually part of completely different products, right? So that's kind of where you start to have some issues. So just to illustrate this, the way that fragment composition actually works in GraphQL is if you have a query with a couple of different fragments spread into it, here one is selecting the name field and one is selecting the profile pic field. In the GraphQL response, those fields just get inlined, right? So whatever the context is, that object, there's no like further nesting for the fragments in the response. It's just, you know, name is in there, profile pic is in there, right? So you can already see that this presents a problem because if we go back to the component, there's nothing actually preventing us from using whatever data was in the like picture component, right? So then if that component wants to remove the field or something, if we're using it, there's a problem. Now, Relay solves this with what we call data masking, where this use fragment will just return only the fields that you actually directly accessed in your fragment. So we kind of do some stuff on the client to prevent that from being a problem, but there's overhead to it. It's complex to implement. So it's not an ideal solution. But the real problem starts when you have different components composed, different fragments composed into the same query that are selecting the same field, right? So here we've got two different fragments that are composed into this query. They're both selecting profile pic, but with different arguments. So one is like size 32, one is size 64, right? So according to you know how things would normally work, these are just going to get inlined, and you should just have this one profile pic field in the response. But which one is it, right? Is it the big one or the little one? Now, according to the spec, what should now happen is that your app should crash. Right? Because this is an invalid query, and so the server is required to just return an error for this query because it's invalid. And so what can happen is, because remember, this could be in a product that you don't write. Like you're working on small pic and you're doing something and you add this profile pic field. In your product that you work on, no problem. Some totally different thing is also using small pic and big pic, and it starts crashing, right? So this is violating everything that we want for modularity, right? It is something where you're going to change something and you have these unpredictable runtime errors, right? That's not modular at all. Now, Relay, it's not baby's first GraphQL client. So what we do is we actually have, in our compile step, we check for every possible way that fragments could be combined, and if any of them have a conflict, it's a build time error. Okay, so that's like way better than a runtime error. But the problem with that is that it is very slow. It's actually super linear in the size of your code base. So you make one little change, Relay has to check if the change you made could affect anything else that's in your code base and could possibly cause one of these conflicts. You know, it's like, how much more could you get done if you never had to wait for a computer? Right? Like, wouldn't that mean something? We'd like to build things so that you're not waiting around for a computer. And, you know, the thing is, even if you get to, you find out about this error, you have to go and change some other product. Like you have to go arbitrarily alias some field or whatever so that they're not in conflict. So it violates the idea that your changes are local, right? You could have something come up in CI and like, there's just no locality of changes, right? When you have conflicting fields. Another place this can come up is this client-controlled nullability proposal, right? So going back to this example, let's say that you have the profile pic component and it's got its, it's selecting the profile pic field. Suppose that the person that is maintaining that component went in and made this non-nullable. You're spreading in profile pic. What's going to happen is the response for your entire component is going to turn into null. So you maybe expected just the picture to go away, but actually like it goes out further and potentially the rest of your component was fine. You could still render the name, but like somebody else's change broke your component. That's not modular. That's not what we want, right? So the thing that we're proposing to solve all these different issues is what we call fragment response keys. So looking at that client-controlled nullability example, currently you're spreading profile pick in. So if that ends up being null, it will make the entire response for this fragment null, right? What we want to do instead is give a name or a key to that spread. And what that'll do is introduce an extra level of nesting, okay? And so in the response, the thing that would be turned null is null, but it's under another key, the key that you provide. So it doesn't propagate out to the entire fragment. Like the spread is now an entity in the response. So going back to that example where we had the two fields that were selecting the same, the two fragments that were selecting the same field, if we have, if we just give them keys, now in the response, they're separated out from each other, right? So they cannot conflict. And you can have, basically this creates boundaries where nothing that's happening inside that named keyed fragment spread could possibly affect anything else. Now we don't want to get rid of the existing fragment spread because we want to maintain backwards compatibility. But with just a few judicious keyed fragment spreads, you can create boundaries between products. So that actually bounds your build times, and it bounds sort of error propagation, right? Wherever you might have an error boundary in your user interface, you could put one of these. And that means that nothing inside there could affect anything outside of it. And it also means that the compiler knows that that's true, and so it doesn't have to check anything outside of that boundary. And so you can get reasonable build times without having to introduce this everywhere, just in a few places in your product. So this is kind of a small change that would make us way closer to the ideal of actually things being fully modular in GraphQL. All changes are local. You can never break other parts of the product. There's one more ingredient to get us there, and Mofei is going to tell you about it.
Hello, my name is Mofei, and I'm here to talk to you about variable level modularity. So let's take a step back and imagine a language that's not GraphQL. Someone told you about a really great programming language. It's new, someone just came up with it. It's really expressive for all forms of graph-shaped data, allows decoupling between the client and server. Here's the caveat. You can only use global variables in this language. The language promises we'll help you compose things, we'll let you be modular. We have functions. You can use functions, call functions, define them. But these functions can only use global variables. What would using such a language look like, and would it be modular? So let's write an example program. So imagine you're writing this language. It's similar to JavaScript, not JavaScript. And you're writing print greeting. Already this is starting to look strange. Print greeting is unable to accept arguments. No local variables, we promised. And it assumes that there is a global variable called greeting name defined somewhere. How would I call print greeting? I will define a greeting name, and I will call print greeting. And now I can print hi Bob. But what if I wanted to greet Alice within the same application? Okay, I can't change print greeting. I can't call it with different parameters. Let me copy and paste that. Copy and paste the variable name and just change both of those. Introduce a new global variable called that other greeting name. It's similar to greeting name, but not the same. And finally, I can print both hi Bob and hi Alice within the same application. So I want to revisit an idea previously brought up by Dave, that an operation may use many fragments, and it may use a single fragment in many contexts. From another perspective, within a component tree, a single component may be reused many times. So let's look at this following code. We have a fragment called item picture. It's probably used with an item picture component. And we have a overall query called talk details that spreads item picture. So this is drawing the modularity picture, as you see, as well as each of the presenter pictures. But I might want to fetch those pictures with different sizes. Now this is where I have a problem. Fragments can only use variables in the global namespace, which means I cannot reuse item picture within this query to achieve my desired result. All variables are global and they have to be defined on the operation. And because of those things, it's impossible for item picture to be fully customizable or reusable. The way to get around this with GraphQL's current syntax is that I'll need to copy and paste. Item picture becomes another fragment, item picture 2, and I'll have a second global variable called size. Not exactly ideal. We can solve this by introducing fragment level arguments. This looks very similar to arguments in a function context. So first, every fragment should be able to specify its own arguments and an argument definition. Here, item picture declares that it needs a variable called size, and everywhere that spreads this fragment can now pass in the desired size, which can be either a known constant literal, as we're using here, operation level variable, or another fragment if the fragment spread is happening from a parent fragment. Relay currently allows developers to use fragment level arguments, but the way it does it is very expensive. The compiler will generate a different version of item picture, name some gibberish like item picture 23456. By discovering all fragment spread sites of fragment picture and generating a whole bunch of definitions. This is a super inefficient workaround, and this should be supported by the GraphQL spec itself. So fragment level arguments allow us to reuse fragments within a single query, but we'll quickly run into issues when multiple operations use the same fragment. So in this picture here that I hand drew, sorry for the bad art, the black dots are queries, the blue dots are fragments that may be spread, and I'm concerned about the item component, which is spreading the item fragment. So let's look at how this could be an issue. Let's say that you're on a team that works on GraphQL Conf UI, and someone on your team is working on the item picture component. They have a wonderful idea. Maybe users would love it if every single picture was blue.
Yeah.
You're like, well, let's hold off on that thought. Maybe that's not the best idea. Let's do an A/B test. See user engagement based on whether pictures are blue. Now, every time you write an operation that uses item picture somewhere, I need to set make blue. And the way I set it is I check whether this user is in the make blue test, true or false. Kind of works out. But maybe a new member joins your team, and they're working on the speaker component in speakercomponents.js. They look at speakercomponents.js, and they see, I need to define make blue. It doesn't make sense to me that things should be blue. I don't know who's even using the make blue variable. I'm going to set it to false. I don't think things should be blue. Now we've shipped a broken A/B test. We missed one out of maybe hundreds of queries that ran on the surface, and not an ideal setting. The root of the mistake here is that every operation that may transitively spread item picture has to check its variables, and it has to know the business logic of those fragments of those components. This forces item picture to be tightly coupled with these other files that don't even directly use item picture. It might be a grandchildren that renders item picture component or spreads item picture fragment. So the fundamental issue here is that GraphQL only allows for two types of values, constant literals and variables defined on the operation level. If we were able to add another value type, this could solve the problem. So in Relay, we've added variable providers, available actually today in Relay version 14. So variable providers is an annotation on the fragment definition and a separate file that defines a function returning a runtime constant of what this value should be. So any operation that uses this fragment does not need to know about the presence of make blue were what its business logic should be. So now we see that speaker component doesn't even need to define the make blue variable, much less set its value. So together, fragment level arguments and variable providers help us solve reuse of fragments across a single operation, across many different operations, and the use of many fragments within the same operation. If you've ever used many fragments within an operation, I don't know how many people here have, namespacing variables is a pain. Size or make blue might be a very generic name, and they might be used in multiple fragments that expect that value to be different. So this also allows us to have each fragment providing its own default value retrieved at runtime. So this helps us with so many problems. Thank you, and I'll hand it back to Matt to follow the conclusion.
Yeah, I'm super excited that Relay managed just a few hours ago to release variable providers. Perfect timing. So great. We have a lot of the modularity pieces built into Relay and built into our complex clients. But there is a limit. We are trying to get these concepts of modularity into the spec. At its core, the spec itself describes how we are forced to entangle both fields and variables across fragments and operations. So in spec 5.3.2, we have field selection merging, which says that any time within an operation that you're on the same object and your response key is going to be the same, you use the same alias or the same field name, that field must be identical. So it needs to be identical in a lot of ways. As Dave was pointing out, it needs to have the same arguments. It needs to also return a compatible type, all kinds of things. Additionally, we have another spec, spec 5.8.3, that says that all variable usages across your entire operation have to be explicitly defined on the operation itself. The operation is the only place in the spec that you are allowed to set a variable value. So we end up in this weird situation where we treat fragments as functions, but then don't give those functions the ability to pass in different arguments. And we do have client solutions for this, right? Relay and other client frameworks can fake modularity. We can, as Mofei said, we can have our fragments and basically create templated GraphQL so that when we're passing in arguments, our compiler actually magically creates every possible version of that fragment that which is fine, I guess, but it bloats the app size, it bloats the size of the query that you're sending down the network, and it's not a great developer experience because you have to run every single one of these through the full compilation step. It's a global build problem. So even though it's possible to push all the work into the compiler, it's not a great experience. Furthermore, I think we're going to have a lot more changes to the spec as people need more advanced features like client-controlled nullability, where having established points where a product can say, at this point, I know everything underneath me works. You don't need to check beyond, you don't need to check my parents, or you don't need to check below me, right? Having fragment arguments having fragments in the response key itself could help establish those boundaries so that we can start iterating on top of those assurances. So the end result of all this is that we've got a few spec suggestions, really two. One, We really, really want fragment response keys. We want something where we can say this fragment is, at this point, you don't have to worry about that field entanglement problem. And we're not saying every single fragment spread should always do it, but we do think that providing a way for clients to say where they want modularity is high value. Additionally, allowing fragment argument definitions gives fragments the ability to act closer to functions so that we can actually, have a picture of different sizes within the same view. This allows us to stack additional goodies on top, right? Provided variables is something I am incredibly excited about. I am going to start telling all the teams at Meta to use it. Like, it's super high value. We've seen it explode in usage. And allowing clients to stack these features that depend on some element of modularity is, again, high value. Combining the two, we think, is basically all we need to have well-defined modular boundaries for components. We don't want to have to walk every field every time across an entire operation in order to know whether what we're producing is valid code. We've got a GitHub discussion that we've seeded. If you want to get involved, please jump in. I am really excited about this. I'm really excited to dig in the workshops tomorrow, work with whoever is interested in this space. But yeah, at its core, while GraphQL isn't quite as modular as I want it to be, I think we're going to get there.
Questions? Are there questions?
Questions? Yeah.
Yes, at the beginning, I probably focused on what talking about, but where aliases fit into that whole, do they not work?
Yeah, so aliases don't work at our scale. It's the same basic premise that so when you have a fragment, you can use aliases. So like when you run into problems, you can always use aliases to get out of them. So if we didn't have aliases, we would be screaming for fragment modularity, right? So aliases at least give product teams a way to get out of the bad state they're in, but they don't learn that they're in that bad state until the whole compilation has happened, and on our code base, that's like a 10-minute process sometimes. So, or they don't even get to that build step until they put their code up for review, and then we have a CI job that does it. And that's like a pretty bad experience. There's no way to like see right at your code that you're causing a problem. You can't put it in the IDE because it's not fast enough.
We know you have them. Give us your questions.
Cool. Oh, yep.
What's the migration path for, I guess, you can add variables to fragments.
Mm-hmm.
It seems like in an ideally modular system, the fragments would have to take variables, they couldn't reference all the variables. But that obviously doesn't make sense.
Yeah, so that's a very good point. It's not necessarily true, right? Like having global constants is like a normal thing, and it's fine to, so we would probably, there probably is a future where internally we're going to invert the default so that you have to explicitly say this variable, like you have to say, here's a variable on the fragment. Yes, I have a fragment argument for it, but every single operation that uses it has to know what this value is. It's that important. So put it there. We we are in situations where we have operations with like 300 arguments on them that all of them have default values and like 3 of them are set every time, but it's a different 3, even though it's almost the same set of like 300 variables on all thousands of operations. So being able to winnow that down to be like, yes, these are the 3 things that this operation does actually need to set, because you can only know it at the operation level context, versus here's things that we can get at runtime, but it has to happen at runtime, so it has to be a provided variable. Or this is something that could be provided globally or could be passed in from a parent fragment, right? Like, but at least then we have the tools to encourage the right level of modularity.
Anybody else?
Yeah.
I guess, yeah, what's the next step in terms of RFP?
Yeah, so next step, we've got the GraphQL working group discussion. The next step is probably on me. I've been sitting on this for a little while to, so the next thing for fragment arguments, I need to put up validation rules so that when you use fragment arguments, you can have the right validation rules. It's kind of unclear exactly what that will look like. There's a few different options. There's also, yeah, basically we need to get a couple RFC1s and possibly a meta RFC1, which is the combination, like the composition of the 2. Yeah. So if there's somebody that wants to champion this besides me, it might happen a lot faster. But, yeah.
Who's next?
Cool. Yeah.
Cool.
We can go to
Karaoke. time.
karaoke. All right, thank you.